All right. So here we're going to, in this section, we're going to cover partial fractions. So here, first, what are partial fractions? So let's say, for example, that, well, just with some algebra here. So let's say I had this expression, 3 over x minus 3 plus 5 over x plus 4. And let's say I wanted to just combine this into one. Well, I know I have a common denominator of x minus 3 times x plus 4. Right, so that will mean that if I were to combine this expression, it would have to be 3 times x plus 4 plus 5 times x minus 3. All right. Okay, and then from here, all right, just simplifying, we would get 3x plus 5x, so that would be, 8x. And then 12 minus 15x, but the last terms here, 12 minus 15 is minus 3. All right. And then all over down here, if I expand this, this would be x squared. 4x minus 3x is positive x minus 12. Okay, so here just some combining of two rational functions here. So the idea here is, well, let's say that this is what I wanted to integrate. Right? I wanted to integrate 8x minus 3 over x squared plus x minus 12 dx. All right. Now, with the methods that I have now, right, then this is just not, it's not a trig sub, right? It's not a simple u substitution. But here, what if I were able to start here and then wind up back here? Right? In other words, write this as a sum of fractions, right? Rational functions. Well, I already know this one, right? Because I started with the partial form, right? So I know that this can be rewritten as 3 over x minus 3 plus 5 over x plus 4. Right? I know that to be the case, right? I just went the other way around. And then now once I'm here, well, this just becomes a basic integral, right? This becomes, right, ln 3 ln x minus 3 plus 5 ln x plus 4, and then of course plus c. All right, so that's what we're going to discuss here, and we're going to go over 3 particular cases, right, in terms of, and the cases all depend on the linear factors or quadratic factors in the third case of the polynomial that is in the denominator. Right. In this case, as we see, these are 2 non-repeating linear factors. So we'll go over that case where it's non-repeating. They're all unique factors. Then we'll go over what happens when I do have a repeated linear factor. And then we'll go over the irreducible quadratic factors. All right. Now, before we get into one of these cases or into the first case, I do just want to bring to your attention, in order for this to work, right, I need to have almost like a proper fraction here, where if we notice here, the degree in the numerator has to be less than the degree in the denominator, right, or else this method will not work. All right, so if, for instance, let's say that we start off where that was not the case, where we have x cubed plus x over x minus 1. All right. Now, in order for me to be able to use this method of partial fractions, I first need to have the degree in the top to be less than the degree in the bottom. So the way we're going to do that is by doing long division. Right? So the first step to solving something like this would be to have x cubed. I'm going to leave a place for x squared, and then x, and then here we get x minus 1. All right, and then I'll start, this is plus. Okay, and again here, long division, here we just have to, oops, excuse me, that's not what I meant to do. Here. This is the setup here, all right? And how I do long division here is I want to match up, I only focus on the leading term here. So how can I get, what do I multiply x to get it to x cubed? Well, that's just x squared. So we get x squared times x is x cubed, and then minus x squared. And then we subtract. So that's 0, x squared, and then we bring the x down, right, plus x. And then we keep going, right? What do I multiply x to get x squared, well, that's just another factor of x. So we get x squared minus x. All right. Okay, x squared minus x, so subtracting, here we get 0, and then we get plus x, so we get 2x. And then we can do this one more time, right? Because what can I multiply x to get 2x? That's a positive 2. So we get 2x minus 2. And subtract, and then this becomes 0, and then plus 2, 2. So that becomes our remainder. So we get this, our quotient, with a remainder 2. Now, how does that help me here? Well, the long division yields this. It's x squared plus x plus 2, the quotient, and then you add the remainder. But the remainder is of the form of 2 over x minus 1, the dividend that we started with. Okay, dx. And now I can go ahead and do this integral. Right now this is, right, x cubed over 3 plus x squared over 2 plus 2x plus 2 ln of x minus 1, and of course plus c. Okay, so just keep that in mind as we start to integrate these rational functions. In order for this method of partial fractions to be valid, we first just have to make sure that the degree in the numerator is larger than the degree in the denominator. If it is not, then we need to perform this long division in order to get it to that form.